Alright guys, the purpose of this video is to recapture later on when you're studying the things we're talking about on your quiz, which is on July 4. So let's go and make that happen. So we're going to be saying there will be 10 questions. It's just a quiz. We won't make it too hard. True, false, MCQ, short answer discussion. It will be delivered via class marker, Earl. We'll do a practice quiz later on before we're done today, just so you're familiar with the tool, you know how it works. So. You will not be asked to write code. However, I will show you some panels of code we've worked with and ask you to give some analysis or discussion or some MCQ questions about it. Shown a image of code. Discuss or answer questions about it. Also, in terms of coding, we have done a couple of good class days on Kotlin, right? So we've done some Kotlin labs. So given the Kotlin labs, which I've, when I say coding here, I mean Android app coding with manifest XML and all that, because that's kind of tricky without tool support. However, I am going to ask you to write some Kotlin code since we've spent a couple of classes on it, right? I expect you to be reasonably familiar with writing a good foundational Kotlin code. You will be expected to write some simple Kotlin programs. And a good way to do that would be to just, as you're studying, you can go and repeat the labs we've done previously. So I'll put out a link to them here so you have that. The test will be just on the class marker tool, right? I will not make it a practical test right now. I won't ask you to go to Android Studio and write some code or whatever. So when I say code, I just mean like type it into the panel of the test tool. So you should have all of your Kotlin labs. They're all out there in Moodle. But here is some Kotlin drills. Yeah, I guess that could be a basic one. Yeah, so you could go and practice redoing this one. We did that 2 weeks ago, I think. And I think there was another couple of good ones we did here. Well, that's an Android lab. Yeah, so this, look right here, Kotlin object-oriented programming. I will be asking you some questions about this, so this would be a very good one to go and review. So I think that too should be enough for your Kotlin stuff. So let's get you the link for that. All right, so Kotlin coding. And some other questions you'll be expected to ask and answer about is Android architecture. And I'll put the questions there in your study syllabus document. Android architecture. And we also talked about the ecosystem of an Android application. So once again, I'll link our lecture notes from earlier. Plus, I think I gave you a PowerPoint, so I'll kick the PowerPoint out there as well. Yes, so here's another thing on object-oriented. So study that. That was from a couple of weeks ago. Anything else? Oh, yeah, elements of Android architecture. That was actually the one I was looking for. So we did a theory discussion on this. We developed this together in class about 3 weeks ago. And I said that that was a foundation, so when we start writing code, we can lead into this and understand what our code does. So I'm not going to ask you to, memorizing the whole thing would probably be a good idea. But in terms of Android architecture, as we go through our review, there's basically a couple of things I want you to memorize. So you should study this document, but in terms, you don't have to understand every part of it for the test, but there will be some MCQs, and I'll tell you what to focus on. So let's carry on now. Android architecture. Okay, I'm just going to turn off screen sharing for a couple of seconds. I'm going to jump into... All right, I'm now going to add this note to your lecture... Oh, actually, I'm not sharing my screen here. Let's reshare the screen. All right. Yeah, so this is something I've been developing over a couple of years. It's pretty comprehensive. This is the Android application development ecosystem, right? It's all the stuff all the way from the Play Store where you sell your app to the library documentation that you figure out how to build it. So that is something that would be good. And I've been talking about this stuff, right? I haven't shown this lecture note before, but on day one when I showed you the PowerPoint's kind of a little bit too wordy. This is like a netted out version of all the key points. And this would be worth spending some time to memorize. So let's kick that into your study syllabus. All right, so now you have this note in your Moodle, so we're all going to remember it. And now everything else we do, we're going to put in this coded document, which is linked over there, so you can get that to there. All right. Now let's go back to here and finish this Lucidchart diagram. And then we'll do some coding. Then it'll probably be around noon. We'll take a break or something. And we're going to scan over, right? I'm not going to do extensive amount of lecture on any of these sheets because we've done it before, but I'll just scan over to refresh your memory of the key parts of it. So, yeah, that was one of our coded documents I linked. Right. Yeah, so what I was starting to say, this could be like a typical question for your Android architecture, Android application architecture question. So for each of the 5 big files listed here, which form the basis of the architecture of the Android app, I don't know exactly how I'm going to say the question, but basically I would just say be familiar with what it does and with or sort of discuss what role it plays in making the app work. Yeah, pretty much that. Just maybe make a couple of practice apps when you're studying, and just sort of look at them and play around with them. So anyway, let's dump this into your study notes. All right, let's go back to Lucidchart now and finish that drawing we were making before. I lost it. Where did it go? I don't think I started it yet. I think I was just starting here. Okay, new Lucidchart. So my training was as an electrical engineer. That's what I graduated with. So I always start by thinking about things from the point of view of hardware. Other people might start to talk about the Kotlin programming language or the operating system. But to me, unless you have hardware, you don't really have much of anything. So we're going to start by putting a reference to the hardware, which is your phone's motherboard, plus all of the cameras and sensors and so on. So Android hardware, that's an open source specification, so anybody is free to download it from Google, and you can go and build your own hardware. People do that. You can get do-it-yourself kits. Unlike iOS, which is closed source, they don't tell you what the memory model is. But Android hardware specification, which includes all of your onboard device sensors. Now, the thing which connects for any device, for your laptop, computer, for the computer in your car, or anytime you have hardware and then you have an operating system, the connective tissue which joins the operating system to your hardware is something called the memory map, right? The memory map. And I don't know if you guys have had any training in electronic engineering, but basically microchips, if you were to open your phone and look at the motherboard, you would see microchips. And you know what microchips are. Those look like little sticks of chewing gum. They're little one-chip computers which do the work of running the algorithms to make the app work. So that would be what you'd see if you open the phone. And each of those chips now, every pin on the chip, its connection to the outside world is with a digital address called a hexadecimal address. So each chip talks to the outside world, it's controlled and it communicates. So microchips control and communicate with the outside world. What are called hexadecimal codes. They're just numeric codes. Now, why that's important is that to control your motherboard, you need to know something called the memory map. So the memory map is the list of all of those numeric codes. And if you know it, then you can write software in Java or other languages. You can control the hardware. So the memory map is the listing of these numeric codes. For Android, we know that because Android is open source, and they say that iOS is closed source because Apple keeps that a secret. They don't want other people to write hardware or software extensions for their device. But it's open source, so Google, Android, the memory map of those numeric codes is open source. So that's the first layer. That is the layer of your hardware. That's the first part of the Android app ecosystem. This is what gives you access to the screen, the hardware sensors, and every other part of the device, the GPS, right? So this hardware is the phone. The screen, sensors, everything else that relates to the phone. Memory, CPU. And the hardware specification is the memory map. Now, the memory map is important because the next layer we have is the operating system, right? So we have a Android, which is based on Linux. Again, all totally open source. If you want to go and modify it and make your own fork of it, go for it. People do that. They make special purpose industrial sensors, for example. So the Android Linux operating system, first of all, it's stored as program code in those microchips down there. So if you were to look at the motherboard, there would actually be one chip, which is firmware, which contains the operating system. When you power up your device, that code gets loaded and it starts running the phone. So the an operating system for any kind of hardware connects the hardware memory map. It connects the hardware because the OS is coded to know them as something called device drivers, which connect to the hardware ports on the motherboard. So the operating system connects the hardware specification to the via APIs, via application program interfaces, to the application code that we write. So then above this, once you've got working hardware and it's been properly configured to work with its operating system, the next thing you have up here is your program code. So the next layer is program code, which is Java, right? Java Kotlin. So once the operating system is up and running, and again it's encoded in firmware and microchips, but we have Java program code, which provides APIs, which provides hooks. And everything I'm saying is exactly the same for iPhone, iOS. Only difference is they keep their hardware specification and their memory map secret. But this is how basically any kind of any Internet of Things sensor, this way of understanding things is applicable basically to any kind of computerized electronics. So above the operating system, we have Java program code, which provides APIs, methods, right? Methods just like we write. The Java kernel provides method calls, which we can appeal to, which we make use of in our code to control, to send and receive control and data signals to the motherboard. I know right now this sort of seems like a little bit abstract, but when we're down in the bushes, especially in later weeks when we get to writing things using the camera and the GPU, it really will help you if you have a mental visualization and a picture of how this works. So the Java provides API, which we call to through method calls to control, to send and receive data. To the Android hardware. So for example, in our lab we're about to get into, we have it so that a user can type a number. They can tap on a field on the screen. They get a keyboard. They can type a number there. That number will be received into the Kotlin code, and it'll be processed and it'll send back a response. All of that happens with API interconnection between our application code and through the operating system to the hardware. Finally, the top level of our architecture is the application code that we write by ourselves. And because to do all of that would be quite complicated, Android Studio gives us some RAD tools, rapid application development, so you don't have to know by yourself how to write all the code to create a field or connect to a click button, a click event on a button. When you drag things using the GUI, using the Android Studio it generates. It's called Rapid Application Development. It's a code generator for you. So the top level is Android Studio, where we write our code. And we do two things here, actually. We write the code, and we also use GUI tools, graphical user interface tools, to design the elements on the UI. All right, so all of these topics, and I'm recording this as well so you can watch the video if it helps you, but these are all things I might potentially ask you about on your quiz in terms of the theory of the sort of the background wiring of how your Android app works. And I will drop this into your study notes so you have it handy. Okay, guys, if you want to take a 10-minute break, it's up to you. It's coming up in the hour. We've basically done all of our test review questions. I don't have anything else to say unless you've got questions. But when you come back, or if you want to keep going without taking a break, it's up to you. But next, we're going to move on into our lab. So I'm going to end up